The mission for extraterrestrial life has moved boundless science fiction stories. Furthermore, it has even filled missions by NASA. Perhaps one of the most beguiling spots in this search is Europa, a moon of Jupiter, which many acknowledge could hold earnest information. Bill Nye, the prominent science individual, is among those who advocate for extra examination of Europa, believing that this glorious body might be fundamental to unraveling the secrets of life beyond Earth. NASA's Pioneer 1 spacecraft, launched in 1977, made groundbreaking discoveries outside our nearby planetary group. This revelation has drawn the attention of some of the brightest minds today, including Bill Nye. What Pioneer 1 found was ionized gas particles successfully clashing and interfacing just beyond the heliosphere, the bubble-like region made by the solar wind. These readings provided critical insights into what conditions might be like beyond our nearby planetary gathering. Could these be markers of extraterrestrial life? This question has captured the imagination of scientists and space fans alike. Bill Nye has long been a driving figure in the search for extraterrestrial life. His passion for the unknown is evident in his interviews and talks, where he frequently stresses the significance of space exploration. The discovery made by Pioneer 1 has also fueled this enthusiasm, offering new data that might potentially answer the age-old question: are we alone in the universe? To understand why this discovery is so crucial, it's essential to return to the beginning of space exploration and the events leading up to the launch of Pioneer 1. During the 1970s, NASA had recently achieved a remarkable accomplishment by sending humans to the moon. This success ignited worldwide excitement within the academic community, and plans were soon in the works to explore much farther into space. NASA's next objective was to study the outer planets of the solar system. However, sending humans on such a mission was not practical. The vast distances and the limitations of 1970s technology made it necessary to rely on robotic spacecraft for these ambitious investigations. At the time, the Cold War was in full swing, and the U.S. was in a fierce competition with the Soviet Union. This rivalry extended into space, where both nations were attempting to demonstrate their technological superiority. The Soviets had made the first significant steps in space exploration, launching the first artificial satellite in 1957 and sending the first human, Yuri Gagarin, into space in 1961. However, the U.S. found success with the Apollo 11 mission in 1969, landing astronauts Neil Armstrong and Buzz Aldrin on the moon. This victory was a turning point in the space race. Nevertheless, the U.S. understood it could not rest on its laurels. The competition with the Soviet Union continued to drive NASA's ambitions to maintain its lead in space exploration. NASA aimed to go beyond the moon, and the objective was now to explore the outer planets. The organization began planning spacecraft that could travel deep into space. One of NASA's first efforts was the Pioneer 10 spacecraft, launched in 1972, which became the first to fly by Jupiter and send back pictures. Pioneer 11 followed the next year, also making its way to the outer planets. However, NASA needed a more advanced spacecraft that could capture detailed pictures and data not just from Jupiter, but also from Saturn, Uranus, and Neptune. This led to the development of the Voyager program. The plan was ambitious: to use a unique planetary alignment known as the Grand Tour to slingshot the spacecraft from one planet to the next using gravitational forces. This alignment, occurring only once every 156 years, would allow NASA to study all the outer planets in a single mission, saving both time and money. To achieve this, NASA built two Voyager spacecraft. Voyager 1 was designed to take a shorter route, visiting Jupiter and Saturn, while Voyager 2 would follow a longer path to explore additional planets. Arriving at Uranus and Neptune on August 20, 1977, Explorer 2 was sent off, followed by Explorer 1 on September 5th of the equivalent year. These twin rockets would continue to make the absolute most astonishing revelations throughout the entire existence of space investigation. Explorer 1 began capturing pictures of Jupiter on January 30, 1979. These photographs revealed details of the gas giant that had never been seen before, including its Great Red Spot, a massive storm that has been raging for hundreds of years. However, Explorer 1's mission didn't end there. After completing its flyby of Jupiter, the spacecraft forged ahead to Saturn, where it sent back even more significant information. The discoveries made by Explorer 1, particularly its discovery of ionized gas particles beyond the local planetary group, have had a significant impact on how we understand the universe. As the Explorer missions continue to send data from the farthest reaches of space, the search for extraterrestrial life remains as urgent as ever. Bill Nye and other scientists believe that exploring places like Europa, with its subsurface sea, could provide the next major advancement. What we gain from these missions could change how we understand life in the universe forever. Every interval, Explorer 1 captured pictures and compiled them to create a colored stop-motion video. Utilizing this procedure, Explorer 1 was able to send back a film showing 10 pivots of the largest gas giant. By February 10th, Explorer 1 had entered the planet's moon system, sending back film of natural satellites orbiting the gas giant. Before long, it found a thin ring of dust and ice surrounding the planet that was invisible from a distance. This showed that Saturn was not the only planet encircled by rings. The ring was under 30 m in diameter and astonished specialists about how little they knew about this planet. By May 5th of that year, Explorer 1 had its closest encounter with a giant planet, separated by a mere distance of 174,000 miles. During this unprecedented event, the spacecraft encountered several of Jupiter's moons, including Io, Europa, Ganymede, and Callisto. The photographs it sent back provided incredible insights into the peculiar universe of natural satellites, as some of them shared very little in common with our moon. These satellites are known as the Galilean moons, named after the astronomer Galileo Galilei, who discovered them in the 17th century through his telescope. One of the smaller moons seen by Explorer 1 was Amalthea, a rosy and irregularly shaped satellite with a peculiar surface composition. Pictures sent by the spacecraft showed that it was composed of ice and silicate materials. The surface became red due to the presence of organic material, and its curiously sporadic surface shows that it has undergone very little internal action compared to the other satellites. Io was viewed as the most geologically active body in the solar system, with numerous active volcanoes and lava flows visible from its surface. These volcanic activities were triggered by tidal heating caused by Jupiter's enormous gravity, making the satellite look more like a volcanic hellscape than a moon. Europa was renowned for its smooth, icy surface covering an immense expanse of water underneath. Many scientists believe that life could thrive beneath the ice, making the satellite a superb contender for extraterrestrial life. A couple of openings were found on the icy surface, indicating past impacts with asteroids and smaller comets. What followed were pictures of what appeared to be the largest moon in the planetary system, Ganymede. This satellite was so large that it surpassed the planet Mercury in size. It is large enough to have its own magnetic field, and the pictures showed that its surface was largely covered in rocks and ice. Ganymede's potentially complex geological history continues to amaze researchers to this day, and it likely harbors a fluid core deep inside, responsible for its strong magnetic field. Another large satellite seen by the spacecraft was Callisto, the second largest of Jupiter's moons. Its heavily cratered surface indicated a history of continuous impacts with asteroids, as well as a lack of geological activity, similar to Europa. It also has a sea beneath its surface, making it another possibility for extraterrestrial life. 2 new moons were discovered by the spacecraft, and were named Phoebe and Métis. The pictures suggested that they are both small and irregularly shaped, much closer to the planet than other satellites. It is interesting to note that the planet itself and the satellites observed by the spacecraft were named after famous mythical figures. The giant planet was named after the eminent Greco-Roman god of thunder, and the orbiting satellites were named after the people who had close encounters with him. Later, following the spacecraft's encounter with Jupiter, a course correction was made so it wouldn't drift forever across the planetary system like the regular satellites. This was done in anticipation of heading towards Saturn around 6 months later. By October of that year, another course change was made to prevent a possible impact with Titan, one of Saturn's moons, and the experience with Saturn were similarly as staggering as the past one with Jupiter, with the shuttle finding 5 new moons, a ring framework comprised of thousands of particles, transient mists made of particles called spokes, and another ring that remained invisible from a distance. It was likewise observed that there were satellites liable for keeping Saturn's rings. However, defined as they are, it very well might be that it is based on these found satellites that the planet's rings look beautiful. In the next few weeks, Explorer 1 caught shocking photographs of Saturn's moons. These satellites included Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. The photos revealed that they were predominantly made of ice, with potential oceans underneath, expanding the conceivable outcomes of extraterrestrial life thriving outside Earth. However, those weren't the only discoveries that amazed the specialists at NASA. More specifically, the moon Mimas, a relatively small moon, had an extraordinary component that energized sci-fi fans for a long time. This moon had a colossal impact crater, so wide that it was given the name Herschel. What made it so captivating was that it caused Mimas to look like the Death Star from the well-known science fiction series Star Wars. This intriguing feature showed very low geographical movement and a significant past contact with an enormous space rock. The other moons seen by the shuttle were fundamentally made of ice, with a couple of distinguishing features separating them. However, maybe the most interesting of the other satellites observed by Explorer 1 was Titan, which was closely approached by the spacecraft on November 12th. At a distance of under 3,000 kilometers, the pictures showed a thick atmosphere that completely clouded the surface. The climate was primarily made out of nitrogen, with the environmental pressure equivalent to the pressure at sea level on Earth. However, at minus 300 degrees Fahrenheit, the characteristics of the satellite suggest that it might be the first body in the solar system, apart from Earth, where liquid could exist on the surface. The chemical reactions necessary for the development of life seem to be present on this satellite, showing strong signs of significant hydrocarbons essential for life to exist. The rocket's closest approach to Saturn was on November 12th, at under 8,000 miles from the planet. By 1989, all planetary encounters were over for both rockets, as every one of the four gas giants had been examined as planned. However, both spacecraft were still functional and were announced as part of the Voyager interstellar mission, an adventure that officially began on January 1, 1990. The new goal was to go beyond the outer planets of the solar system and, if possible, even beyond the more defined solar system. The specific objective was to gather data on the area of space dominated by Earth's magnetic and solar fields, as well as the interstellar medium. On February 17, 1998, Voyager 1 became the most distant human-made object in existence, outperforming Pioneer 10 at a distance of almost 70 astronomical units. By September 2017, 45 years after its launch, the spacecraft was still operational, sending back data from its instruments to NASA's Deep Space Network. It was astounding to scientists that the vast astronomical ray telescope and magnetometer still worked properly after more than 40 years in space. Now journeying into interstellar space, scientists hoped that something out there would take note of the message we had conveyed into the universe. As Voyager 1 and Voyager 2 ventured further from the Sun, their missions took on new importance. Voyager 1 entered interstellar space in August 2012, marking humankind's first excursion into this peculiar area. This accomplishment gave scientists an incredible opportunity to study the conditions of space beyond the heliosphere, the protective bubble surrounding our solar system. Voyager 1's data has been instrumental in understanding the nature of astronomical rays, magnetic fields, and plasma interactions in interstellar space. Voyager 2, meanwhile, continued its mission to explore the outer edges of the solar system and eventually entered interstellar space in November 2018. Its trajectory provided significant comparative data to that of Voyager 1, enhancing our understanding of the solar system's boundary regions. Both spacecraft carry a golden record containing sounds and images designed to depict the diversity of life and culture on Earth. This record serves as a message to any possible extraterrestrial civilizations, showcasing humankind's desire to connect with the universe. As the Voyagers continue their journey, they also contribute to the broader field of cosmology by observing phenomena such as the interstellar medium, the nearby interstellar cloud, and the interaction of solar wind with the cosmic environment. Their discoveries have provided insights into the structure of the heliosphere and the nature of the interstellar magnetic field. The data from both spacecraft is also crucial for future interstellar missions. As technology advances, scientists and engineers are studying the Voyager missions to develop new spacecraft capable of traveling much farther into space. This includes potential missions to explore nearby star systems or to investigate the limits of the Milky Way galaxy. The legacy of the Voyager missions lies not only in their significant discoveries, but also in their role as ambassadors of humankind's deeper exploration of the universe.